Okay, welcome back folks to DCT Lab, and for obvious reasons I am Mr. DCT. So in today's video we are going to be answering on West Mock Computer Science Paper 3, section A, that's the programming part, right? So by the end of this video you should have something like this, which is the expected result from completing the task. For those of you who already attempted it or have done the question paper already, you know what I'm talking about. Okay, so without any wastage of time, let's just dive in. So here's the question paper here. I highly recommend you download it, then open it and go through it. Like, I won't be reading this introduction because it will be like you watching me read text, which will be a waste of time. So read through it, get the idea of what it's talking about, then you can pause the video and continue. But just to give a clear idea, like a brief summary of what the program is, well, it's basically like a maze, I can say, like you are in a maze finding your path, like the best path, right? So let me put it this way: like you are being given a grid, right, a matrix, and with values in it, and you find your path to the bottom right corner. That means you always start here at this top left corner, and you find your way down to this bottom right corner, and the path you take, it should be in such a way that if you add the numbers to that path, it should be less than any other path. Okay, let's take an example for this case they are giving us, right? So they said that enter the number of rows, we have 4, number of columns 4, so it's a 4 by 4 matrix. Now same, enter the energy values for the labyrinth, and if you do that, that means you put 2 3 1, in fact you just fill the matrix, right? Now you should be able to compute it and give the minimum energy required. That means here in this case the minimum energy is 12. The same minimum energy required to reach the treasure is 12. The treasure is at this bottom here, so that's the goal. The rules here is that you can only move forward and downward. If you read through it, I don't know, just read through the question paper, you understand what I'm talking about. You see the place where they say minimum, like they give the rules, right? So I won't be reading the text, so that's why I highly recommend you read through the problem statement, understand this analysis and development before you dive into this video, right? So that you understand what I'm trying to say. So that's the rules. You can only move forward and downward. Now let's compute this. Why is this path, if you look very well, the path, now they say the path taken, bracket 1 indicates the chosen path. So just like binary, like 0 stand for off, 1 stand for on. So the path taken, like if you see 1, it means the path taken, and if you see 0, it means that the path not taken. So if you look very well, this, if you trace this path very well, you see that we have 1 1 1, we descend here, we have 1 again, then we descend down here. So this is a kind of like the shape of the like the pattern taken. I don't know if you can see very well. So it's like this, you come down and you descend like this. Okay, so anywhere you see 1, that's the path taken. Now let's compute to see if the energy required is correct. So if you take 2 plus 3 plus 1 plus 1 plus 2 plus 1 plus 2, all of that will sum up to 12. And if you decide to take the other way around, like instead 2 plus 3 1 4, then come down like this, the square is going to be probably more than 12, and if you take this other part, it will be more than 12. So that's basically it. You look for the path starting from this top left corner to bottom right corner, and the sum should be the minimum amongst all, right? So yeah, that's basically it. I hope you get the point. Okay, so let's dive into the program development. And to make our work easier, I make this simulation so you better understand well how to approach or to answer the question, right? I don't know whether you can see this text very well. Let's first of all read the question. The same under the this subtopic program development, right? This is where we start answering. Say question 1, state the programming language and development environment you will use to implement the program. Well, we are going to be using C. That's the standard language used in GC, right? I hope you are also using it's true that they usually put Pascal, but Pascal is old school, and I've not really seen anybody using Pascal in the GC. So the standard language is going to be C, and I hope that's what they're using too. Now, and the development environment, most of you will be using Dev C++. It's an IDE, but in this case, if you look where you see that I'm going to be using VS Code here. It's true, you never see VS Code in the GC room. They're always going to provide you Dev C++. It's IDE, but in the environment doesn't really matter, right? The integrated development environment, IDE, it doesn't really matter. All it's about the code, right? Okay, so first you have your compiler. Now they say consider the labyrinth grid. I hope I'm pronouncing this word correctly. The labyrinth grid below with the energy levels provided. Okay, so we have this is what they're given to us, 3 2 9. In fact, it's a 3 by 3 matrix, right? Okay, that is figure 1. Let's say A, draw and fill the corresponding energy grid array for the above labyrinth grid. Okay, like I told you, I made a simulation to ease our work. So under question 1, right? So here is the rule here. That is the energy grid, right? Is taking indices like the row I, the column J, and it's going to be the minimum from above. That means the minimum here. Like let me say, if you are here, the minimum above, but if you are like me in this middle here, the minimum from this above here, which is 2, and from left here. So you compare. If you want to maybe check input this value or compute this value, you check the minimum between this one, the top, and the left, and you take that minimum plus the current position. Anyway, you understand better when we continue, when you move along. All right. Okay. So here's what we have here. We have 3 2 1, basically the grid, right? Now the energy. Now I made a good simulation here in which you understand how I left from here to here to compute this energy that you see here, right? Which is the answer. They want us to compute the energy grid. So let me open this tab. Voila. So how do we compute this energy grid that they are asking us in number 1B? So it's really simple. Okay, so this basically our matrix, and the indices already indicated. We have the row and the column. This is a 3 by 3 matrix. So at index 0 0 0 we have 3. So our first energy, the first energy is always going to be grid energy is going to be the same as that of the labyrinth grid, right? Okay. Okay, now the start. Okay, we have energy grid 0 0, which is this 0 index 0 0 is 3, is going to be the same. That means the labyrinth grid 0 0, which is 3, is going to be equals to the energy grid, like I said in the very beginning. This is going to be equals to this, since it's the first starting point, right? Now let's move on. First row, this row, right? We are going to move right, so we move one step right, and that is going to be, you want to do it in indices form. That is energy grid 0 1, index 0, that means row 0, column 1. Now column 1 is this, so it's like saying 0 1, right? So 5 is going to be equals to energy grid 0 0, that means you add this, you take this 3 plus labyrinth grid 0 1 plus this. So that's basically how you calculate the energy. And again, you continue doing that. In fact, we will continue. Let me just make sure you're understanding. So you take 3, that means 0 0, you take this 3 plus the labyrinth grid, which is that's the next step, right, which is 0 1, index 0 1, which is, and it's 2 that is in that cell. So you take 2 plus 3, which is going to give us 5. That's how we got this 5. Now you move again, right? That's 3 plus 2 equals to 5. Okay, you can only arrive from the left, right? You are only moving from left to right. Okay, moving to the next, we have how to get this 14, right? So first row again continuous. We have energy grid, that is 0 2 in the 0 2, which is row 0. That's this first row here is row 0. So we have row 0 and column 2. Column 2 is this. It's going to be equals to 5, this 5 plus 9. What is 9? Index 0 2 of the labyrinth grid. So we are going to take 5, that's the current position, plus what we have in the labyrinth grid, and 5 plus 9 will give us 14. That's how we got our 14. Okay, we continue. For 4 now, we move now down. So the first step was to move horizontally to the right, and the second one now is to come down here, like, I don't know, move downward. Remember the rules, you can only move right or downward if you have read the instruction very well. Okay, so how do we get this over 4 again? The first column, which is this, we move downward. Now energy grid, this in this arena energy grid, that means index 1 0, this index 1 0 is column 0. This first column is going to be energy grid 0 0, which is this 3 plus labyrinth grid index 1 0. I don't know, are you getting, like, are you understand what I'm trying to explain here? I think this simulation is really perfect for you to get a core idea of what is going on here. Plus the labyrinth grid, which is 1 0, that is index row 1, index 0. So we have this. So I'm going to have 1 plus 3. You are going to have, I hope I'm not making a mistake here. The labyrinth grid is index 0, that is column row 0. Sorry, we have labyrinth grid row 0, row 1, pardon, and which is 1 in that position, plus energy grid 0 0, which is 3. So we're going to have 1 plus 3, and that will give us 4, right? That's why we have 4 here in this position. Now you now look at how we are going to calculate and get this 10. This one is going to be a little bit tricky, right? So how we do that is, we take, I don't know where I recall when I said we take the top and compare with the left and see the minimum between them and plus it with their current cell position. So here's what we are going to do. So the middle cell is going to be, we come from above is 5, which is energy grid 0 1, that means 0 1 is 5, and it's equal to 0 1 is 5, yes. Then now we come from left, which is this 1 0, which is 4. Now we going to compare, like, we pick the minimum between 4 and 5. If you compare 4 and 5, the minimum is 4, right? So you take now that 4 and add it with the labyrinth grid 1 1. 1 1 is this position here, so that is 6 position, that is index 1 1 is going to be 6. So what do? We take 4 plus 6 and you're going to have 10. Again, you continue the process. I don't know if you can continue from here, but you get the idea. So right now we are going to move from above, that means here, we are calculating this next one. Okay, we move from above, which is energy grid 02. That means row 0 column 2, which is 14, and we move from left. That means we compare this and this to get this. So between 10 and 14, which is the minimum? 10, right? So take that 10 plus this position in the labyrinth grid, and that position is 2. That's why we take, well, that's why we have 12 here, because 10 plus 2 is 12. Again, you do the same thing. You move down here, you compare this and this, right? If you compare 10 and 12, you are going to discover 10 is a minimum. You plus it by this labyrinth grid, the current position right in the labyrinth grid, which is 3. So 3 plus 10 is going to be 13. You continue the same thing here. So we're going to have 12 and 13. You compare the two. 12 is smaller. You take 12 plus the current position here, which is 1, and 12 plus 1 is 13, and that's how you get it. So basically that's it. I hope you got the explanation, right? Okay, so that's number 1A. Now number 1B. Let me drink water. B. Okay, sorry. Number 1B, we have, they say, draw and fill the corresponding path array that shows the optimal path that led to the treasure as described in the problem description. Okay, so they want us to trace this path. I think the path we took was like this, right? We move down, left, then down, and yeah, that's it. So we trace. I'm going to trace from bottom right, that is here. At each step, we pick the neighbor with the lower energy grid value. So basically that's it. So if you look at the indices, we have 0 0, which is 3 here. We move to 1 0. 1 0 is 1 here. I hope you can see very well. We have 1 1. 1 1 is 6 here. We have 1 2. 1 2 is this 2 here. Index 2 2 is this digit 1. And if you do that and sum all of the cells, you discover that 3 digits, all of that sum will give you 13. So that's the lowest energy value required for the minimum energy value, right? That was it for question 1B. And you could look very well. If you trace very well, you have this 1 1 1 1. It's the same, this shape. It form like kind of like a 5, like a semi 5, I don't know, or an S anyway, something like that. Okay, continuing, we have question 2. It say, in your chosen development environment and programming language, declare as global identifiers the labyrinth grids, energy grid, and path arrays, and initialize the labyrinth grid array with the energy values as shown in figure 1. Write your code below. Okay, this figure 1 here. Let's move to question 2, which is declarations of variables. So we are going to start by including of course our library std.h, which stands for standard input output, and is responsible for the printf and the scanf statements in C. Now we are going to define a global variable called max, and it's going to contain a value 10. This max is going to be like the maximum value someone can input in their array size, right? Since we are dealing with a 2x2 matrix. Now these are the global arrays that we are going to declare outside of main. So any array, any variable declared out of the main function are considered to be global variables. I hope you know that. Okay, so they say we should declare the labyrinth grids, which is going to be a 10 by 10 matrix. Again, you can put any value here. For this case, we have a 3 by 3 matrix here. I will propose you put 4, yes, just to keep space for the null value, right? you put directly 3, you may have some comparison, I don't really know, but it's always preferable to put one number ahead of the array size for the null, for those who know what I'm talking about, the null value, right? Okay, so you do that. We have the labyrinth grid with uh, the size 10, because we declare our max as 10. We have our energy grid, again the same size. It's a 2 by 2 matrix, that's why we have all of this 2 right, the same part. Then now we're going to use declare our global variables, which are going to be the rows and the columns. Like the rows are going to be basically how many rows are there and how many columns are there, like just like that. Okay, now we have they said we should write our code below for the labyrinth grid. Okay, so basically, if for figure 1, concerning figure 1 here, we can declare an array, a 3 by 3 array. So in figure 1 we have 3, which is this, that means the size is 3 by 3. Now we can give it this value just as is being done here. We have 3 to in fact fill the array. Now we're going to use a nested loop here. So for int I equals to 0, I less than, strictly less than rows, that means it's going to count 0, 1, 2 and stop from there. Why? Because we have given our rows number to be 3. So when I is going to arrive 3, we're going to stop. Then the inner loop is going to be incrementing again from j equals to 0 to j less than columns, which is the same size. So what is happening here? So let's just take for the first case. We have I equals to 0, that means I is 0. We have j also equals to 0, that means labyrinth grid 0, 0. We're going to, it's going to be equals to figure 1, this figure 1 here, and we input the, we give it the value 3 here, right? So by just like transferring this figure 1, right, and representing it in labyrinth grid, that's all. Again, just a hint here, examiners want to see like 3 arrays declared globally outside the main, right? Rows, columns, and should also be global, so all subroutines can access them, right? Okay, so these rows, columns, you should declare them as global variable, because you are going to be using them in your procedures as we proceed along down here. Okay, now question 3 we have, it said implement a subroutine called fill energy with these parameters: labyrinth grid, energy grid, R, C. R and C are just the column and rows. Now that takes a parameter 2 arrays, which is the labyrinth grid and the energy grid. It then fills the energy grid array as described in the problems analysis, right? I hope you read the problem analysis up here. Say do so by developing the algorithm below. Okay, here's one cool thing before we continue, like one kind of advice to you guys. If you know how to convert pseudocodes or algorithms into C, then you are already like 99% ahead of most students, because even if you don't know programming, right, there are some things that you can just pick your marks. Like let me say, first of all, filling like this number 1, question 1, A and B. There's no programming needed here. You just have to use your normal reasoning and fill and draw other shapes. Now question 3 here is asking about reproducing, like converting this pseudocode or the algorithm into a program language. So if you are able to read pseudocode and convert it in a language, then that's all. You don't need to think about the logic. They have implemented the logic here. Here's a core logic given to you just for you to type, and that's all. So if it's that they say that implement this fill energy algorithm yourself, that means think of how to be doing and computing all of these algorithms and figure out how it should get the energy yourself, then that's when it becomes tough. But the algorithm has been given to you just to convert it to a program language, and that's it. So it's very easy. Okay, now question 3, which is the fill energy, is basically to convert this algorithm Now I know some people will be like, this is too complex, I'm not understanding. Well, I'll try my best and break it down here. But again, it will not really be necessary for some students who just, I hope you can see the screen very well. Here is more of people who want to know the why behind things, or like I want to teach you programming, not coding. You know, sometimes schools teach coding and it's as let me say teaching somebody typing than writing. I don't know where I get the point. When you are coding, you are not thinking. Like, well, this part here, let me say, they say convert this algorithm into C program, that's you are coding. But if you are to develop this algorithm yourself, then I'll tell you you are programming. Programming, you have to think and come out with the solution yourself. So in this case, you are just coding, right? So that's basically, you cannot program anything here. Okay. Now, again, another thing, when I say write a procedure, right, a subroutine, right? Subroutines are different from functions. When I talk about subroutines, know that there are programs that they always start with void, and they don't return any value. So subroutine, you start with the void. If it was a function, you start with int. And subroutines, they don't return a value. You don't see any return something down here below. And if it was a function, you could have seen a return specific value here. That's why we call a main function as function, because at the end we have return 0, right? It returns something. So that's the key difference between procedures or subroutines and functions. Okay, so again, they say procedure fill energy, you pass in the parameter and you begin. In fact, it's all about reading the pseudocode and reproducing the program language. Nothing difficult. In fact, like I said, you are just coding here, you are not programming. Okay, so we define our subroutine, which is field energy. Now, base top left, that's the top left, right? You can recall this our grid here. This top left is this 3 index 00 here. Now, so we have energy grid 00 equals to labyrinth grid 00, so they all contain the same value. Okay, now for we are going to use a for loop here. Again, it's still just in fact, I don't know what I'm explaining here. It's just so clear. I don't know, maybe I'll just move so fast here because it is something that you can just get it. So when you say for j, they give this how they write from here to here in sort of like when you assign something into a variable. This is how you do it in pseudocode. So we say j backward arrow 1. This means j equals to 1 to columns. Now when you say 2 columns, that's when you have to reason it out now that this is just a for loop, and they're basically saying that you declare first of all your integer in j, which is good. You can also declare this as your integer maybe outside here. Maybe say in ij before you start using it, so that when you come inside the for loop, you just say for j equals to 1, j less than columns, then j plus plus. This j plus plus simply means you are incrementing. That means you are adding j by 1 each time. Okay, so you pass you do this energy grid j0, energy grid 0j, you give it equals to energy grid 0j minus 1 plus. In fact, that's it. It's just so clear and easy, right? So energy grid, that means when I say 0j, well, first of all, our j is 1, so that is, we are basically saying index 0 1, right? Because j is 1. What is index 0 1? You come back here, this 0 1, we are talking about this position 2, right? We see index 0 1 equals to energy grid 0j minus 1. What's j? J is 1 minus 1, that's 0. So in the 0 0, that means we are calculating the energy grid, right? So we are going to take index 0 1, which is this 3, plus index 0 0, which is this in the labyrinth grid. So we are going to take, okay, where are we? We are going to take 3. Index 0 0 is 3, right? Now plus labyrinth grid, which is index, let me scroll like this way so you can see clearly. Okay, I'm going to do that plus labyrinth grid, which is index 0 1. Remember our j is 1. 0 1, what is 0 1? 0 1 is 2, right? So we are going to have 2 plus 3, and that will give us 5 to fill here, and that's basically it. Because if you look at index, again, you have to know how to read all of these array stuff, the rows and the columns. Sometimes it's even three-dimensional. We have I, J, K, or maybe any variable you decide to represent the third dimension. Okay, so energy grid 0j is simply position 0 1. What is 0 1 here? 0 1 is this position. That's why we have 5 here, because we took 3 plus 2 and it gave us 5. Again, I'll not be explaining all of this. You can apply the same thing. The same thing applies here for I. Now the logic here, now this is where we are in the middle. That means if you are in this position, let me say 6 here, right? How do you compute and get 10? Remember, the logic was to take the top, you compare it with the left, and you see the minimum, and you plus it with this current position that is in the labyrinth grid, which is 6 here. So compare 5 and 4, we have 4, which is the minimum. We plus it by 6, we are going to have 10. That's why we put 10 here. That's basically what this algorithm is doing. You can compute it yourself and you see it. Just do some dry running and you see, right? Okay, so just a hint here, they say the algorithm is given in the paper. So like I said before, your own work is just to implement in C. So marks come from correct loop structure. Like if you structure a loop very well, you get marks from it. And then the if else conditions, so don't flip any condition. So use this correctly, and in fact just type exactly. If you, like I said, you are, the same thing applies in my year 2025, 2024. They always give you a pseudocode or an algorithm for you to convert in a program language. Okay, so just practice how to be converting pseudocodes many times into C, many times. You discover you already be ahead of many students. Okay, I hope this video is not taking too long. So 32 minutes. I wanted to do it really fast. Okay, this is question 4. Let's finish it before 4. I don't want it to reach 1 hour. No, it's too long. So question 4, implement a subroutine called optimal path. Now with this parameter, we said that takes as parameters 2 arrays, if then fills the energy grid as described in the problem analysis. Do so by developing the algorithm below. Again, they are giving you an algorithm, just convert it. GCC, I don't know, they have just choose the complex stuff and given you just the bay. In fact, everything is set for you. Just convert this algorithm. Okay, so again, it's a procedure optimal paths. Again, procedure start with void. I want you to know. If was again a function, you start with int, and functions end with return values, while subroutines that don't end with the return value, just like that. So again, it's just basically repeating the same thing, converting this into this. That's why I just never want to like type in this, because like I'm looking at the solution already and coding. That's why I said coding is actually different from programming, and that's, I'm not here to be showing you coding. I want you to understand programming. So that's why I'm here to explain the logic of what is going on that hood. Some teachers will not really actually explain how this energy grid is gotten, or because the algorithm has been given to you, right? You are just converting from algorithm to C, but not knowing what is going on. So that's why I'm here, right? Okay, again, you just declare your variables ij. You set your I to be rows minus 1. So I is an integer. I equals to rows minus 1. Remember, our global variable for rows was 3, right? If you recall, we were here, right? Or is it here? The global variable here, that's 3, right? So I'm going to have 3 minus 1, that is 2, right? Again, do the same thing applies in, we have the path at the very beginning is set as index ij is going to be 1. That means the first mark, that's why we all start at the top. Let's start our diagram. The top left corner, this 3 here. So we set it to be 1. That's why we're going to print us the path to be 1 1 1 1 to form this. Again, that's just the logic. Everything has been given to you just to convert it. Okay, again, if else. So the same, if I is equal to 0, again, nothing difficult here. And another thing is, some people get confused between how to represent or in C program. Well, or it's just like in logic gate, right? To just true only when either one of them is true, right? And also if both of them are true. So in C, you represent it by this straight lines. I don't know, how do you call it, pipelines, right? I know in cybersecurity we represent like when you're typing a command, maybe in bash you pipe it to something. So you just write this to the vertical keywords. And if it was if it could say and, you could use this ampersand sign. How do you write this? Like a funny 8, I don't know, you write 8 2 times, right? That will be the ampersand that represent ampersand, like this. Voila, this represent and. So if they could say that if I is equal to where are we? Voila, here. If they could say that if I is greater than 0 or j is, if they could have put and here, that means and, right? Again, I'm making this video to be too long, and we represent it with 2 ampersand sign. They call it ampersand. Okay, so that's it. You decrement it by j. You decrement j by 1. Decrement is simply you take j minus minus, or another way of doing it is we could take j, right, equals to j minus 1. It does the same thing. Another way of representing it could be j, right, you take minus equals to 1. The same thing applies. So that's just some things you need to note and be aware of them. The video is already 37 minutes. I wanted to finish it in 45 minutes. Okay, let's be fast. Okay, you do the same thing right till you end here. The same logic applies, right? Again, you're just converting pseudocode to a programming language. Now, number 5 here, they say write a code statement. I want to see the hint here. They say while loop condition is I equals to 0, GCT stop when both reach 0. Okay, the entrance is self gates path. This is okay. At the very beginning, the path 0 0 is going to be 1. Like I told you, that was 3, where 3 was found, right? Okay, number 5 says write code statements that will display the maximum energy needed to reach the treasure. Now this one is simply just to calculate that path that we have traced, some other digits in the cell, right? That's number 5. This is the code for it. So the maximum energy needed is simply going to be equal to energy grid rows minus 1, column minus 1. And here is it. You can use your normal printf statements, in which we are able to use because of the SCGO library that we included at the top. Now we're going to be energy grid rows. Remember our rows was 3, right? Oh yeah, if I'm not mixing them. So we're going to be rows minus 1, column minus 1, and we're going to print that here. Why? Because what was our final calculations here? Optimal path. Where's that place? Anyway, let's just continue. Okay, so basically that's what you're supposed to do here. The energy grid, just grid row minus 1 and column minus 1. Okay, now there's a correction here. This number 5, they said maximum. Normally they just made a mistake. This is supposed to be minimum. Again, remember we are calculating minimum energy needed. Why should we calculate the maximum energy? I mean, if it was asked to be maximum, we could have been doing this. Our sample up here could have not been 12 as they did according to them. Where's that place? Up here. Well, I'm not being told because I calculate minimum, right? So just probably a mistake by the GC, no, by the examination. The people who set it not West, right? The vigilator, the examiners. Okay, we are almost running up. This already 40 minutes, 5 minutes left, we are done. So there's a write a subroutine called display that takes as parameter the energy grid and parts and display their content. So how do you do that? We are going to be using nested for loop. So first of all, a subroutine, we say void display. Now print, just to make user friendliness, you can say printf energy grid now /n for next line. Now I want to use a nested for loop here. So for I, which is going to start from 0 to I less than rows, we increment it by 1. Now we do it, we come inside here, we say j, the same thing. Now what we're going to print is the grid, right? So let me just explain what's going on here. We have I 0, j is 0 for the first iteration. So in this grid here, now I say printf 5% percentage 5d. Why am I putting 5 in front? Just to say that the minimum character length is going to be 5. You could put maybe 2 or 4 or whatever. So the minimum character is going to be 5. Now I'm going to say energy. I'm going to print the energy grid, that means index 00, and if you know from our example up here was 3, right? Index 00 was 3, so we're going to print 3. Again, you iterate again up to this condition is fulfilled, right? And fill the grid. Now to print out the path, printf path. Remember from very beginning they said the path 1 represent the path and 0 not taken, that means it's not a path, so you only track that path that is containing 1, right? Okay, so the same thing applies here. You nested for loop, then you print the path ij. You're going to iterate so many times till you feel you satisfy the conditions. Okay, this way 42 minutes. I'm trying to round up very fast. Now the number 7 says develop a main program within which you should include all necessary variables, declaration, and enter any values needed. Then call the subroutines defined above in correct order. Okay, here's where our main, we're calling our main function because it's going to have return 0 at the end, right? So you're just going to declare our global variables here. That we are not going to need our local variables, right? We just declare them at the very beginning. I think was here as global. So this int row column, they already spans through all the code because they are global variables. That's why in here we don't need to declare them, right? So we are going to initialize our labyrinth grid plus path to 0. I think I should even show you the code here. I think it was here. Okay, I'm just trying to run up very fast. Anyway, the final code is going to be in my GitHub. I'm going to provide a link in the description below so you can see it. Okay, so they say initialize the labyrinth grid path to 0, right? So first of all, the labyrinth grid is first of all empty, so we need to initialize everything to 0. Again, it's going to be a nested for loop. The row, the column, filling. Since it's why is it nested for loop? Because we are dealing with 2D dimension, right? So one is going to be handling the rows, one for loop is going to be handling the columns. So we fill all of it to 0 0. At first there's no path being traced, right? Now we call our fill energy procedure and our optimize path procedure or subroutine, right? Okay, here is it. We call our fill energy, we call our optimize. Now we print the minimum energy. That's going to be, that's the question 5 that we had here, right? Now we call the display. Again, the same thing here. So printf, I hope you can see the screen well. Should I zoom it? Okay, I hope you can now see. Okay, so printf minimum energy to reach the treasure. We want to percentage g. Now put minimum energy. Remember the minimum energy was just the energy grid array, we pass it with this indices row -1 and column -1. Then I will go on the display function to display, right? But again, question 8, we are almost going through. She said 45 minutes. Oh god. Okay, we say modify the code in the main program such that the user enters their desired energy level. Run the code, print the modified code, and the output obtained. Okay, here we don't want the user to input their own energy, right? So here's an example, and here is after this I'm going to show you a demo. Let's type in this value that we got up here so that we can see if our result is correct. So we have user enter their own grid, so printf enter row, semicolon, and your statement, your C statement with a semicolon at the end. So scanf %d, the number of rows, you enter the number of columns, ampersand sign, this addressing that you store this, the value you take, you store the value you enter here in the address of rows, the same thing. That's what is happening here. Now printf enter energy values. We have a nested for loop to input all those values. So one is going to be handling the rows, one is going to handle the columns. Again, it's a 2D dimensional. Just notice, if you have 3D dimension, it's going to be a nested for loop of 3. That means a for loop inside another for loop and another inside another for loop. If you just 2D, only 2 for loops. So we have scanf %g ampersand labyrinth grid ij. So we're going to input all of this inside here. Now we're going to reset the paths, then rerun, because we have to wipe everything right before we run again. If not, the previous value is going to be printed again. So we have to reset everything to 00. Now we call the energy field procedure, then the optimized path, then we print the minimum energy percentage is going to be energy grid, which is that our formula, row -1, column -1. So in this test, voila, I think our test was up here. We're around up, right? Let me see the last question even. The last question said print and copy our entire code and obtain the output. Yes. Okay, I want to test this. Voila, we have 329. So let me open this. I just want to make sure you see my screen. I hope you can see my screen. Let me clear. Let me run the program. Okay, so to fields, I'll enter our dimension was 3 by 3, right? So rows 3, column 3. Now the first inputs were 329, right? We have 3 space 2 space 9. Then the second line is we have 162 and we have 831. 162 831. 162 831. Okay. 162. Then we have 831. Right. Okay. Voila. I said the minimum energy reached is 13, just as we calculated. So the first of feed the energy grid using that our procedure. You see, how this happened, not just blindly coding without understanding the real logic behind it. So we explained this in the very beginning, how this is done. Now how this part is being traced. Also we have 11111 here. So this is the lowest energy path. The one with 0 are the ones that are not taken. Okay, so I think this is 48 minutes. That's all about the video. And this video is going to be my GitHub account. So I have a repository that contains computer science paper 3 questions. You will see June 2025. You have my master class algorithm pseudocode convert. Voila, this series I was teaching how to convert pseudocode into C program. You can check this repository and even my tutorial series on that on YouTube. I also have June 2021 and this Northwest Mux. I have not yet committed this one, so I should do that. By the way, if I hit git status, and I see that it's not yet committed, so I'll just do it by the way right here live so that you can see it. So git add git commit -m. So how should I say? I will just say Northwest Mock, right? Northwest Mock. Let me just say section A. Okay, now git push. I'm sure I'm in the main branch -u origin main. Okay. Oh, could not resolve host config. Oh, it's as if I'm not yet connected into my. Anyway, by the time you're watching this video, it should already be available there. It's as if unable to access. It's as if I change the link. Yeah, I probably change the link for the repo. But anyway, no problem. By the time you'll be watching this video, it should be already available in my GitHub account. I'll provide the link below. So basically, that was it for today. If I know you guys are writing this May, right? I think it's the 15th. If you want me to solve another June, another mock, probably Southwest mock. I tried to look for center mock, but I did not find it. So the next upcoming video I think will be 2. I'll solve 3 mocks before you write your exam. So I'll solve, like I've solved Northwest mocks. I'll solve Southwest, then Holy Infant, either Holy Infant or Bezok, something Bezok mock. I don't know, since I did not find center mock. But anyway, if you have center mock, you can send it to me. Again, that was all, and thanks for watching. I hope this video was not too long. Ciao, Mr. DCT.